Good afternoon, everyone. I hope you all are having a good day today. So before we get started here, are there any questions I can address about the homework, about anything we've covered so far, anything we will cover? Let me know if there are any questions. So if you're joining us via Teams, it looks like there was a pretty substantial update to the interface of Teams. So if you're having any issues with anything, certainly let me know. Hopefully you all can hear the audio okay. There's no issues with that. Trust someone to let me know if there are. But beyond that, certainly let me know if there are any problems with it. But before we get started here, I've got the quote up here. Self-reflection is the school of wisdom. That's the textbook quote that they found. I didn't come up with a quote. Anyone want to take a crack at explaining what this means? I've got no idea either. So yeah, it's just kind of here because we're talking about one-on-one and just general recursive relationships. So when we talk about a recursive relationship, the main thing to keep in mind is that it's a relationship with a table. So we have a table that has a relationship with itself, and we of course call that recursive. So kind of backing up a little bit, thinking about this in more general terms, we have this standard organizational chart here. So at the very top of the organizational chart, we have the managing director. This would be like the CEO inside of most firms. But you know, the textbook author, I believe, is British, so they call it managing director a lot of times. But just think of that as a CEO. And then below the CEO, you have your different departments, and then they have a boss associated with each department, and then the boss has various employees within inside that department. Very basic organization chart. Probably would see one a lot more complicated in practice, but let's just kind of show some of the basics of what you may see. So within this, we look at this, we see that there's employees, Alice, Ned, Andrew, Claire, so on. All of those are employees, but the employees have a boss associated with them. So we can model that in several ways. Here's one way we can do it. So you have the department table here, where we have information about the department, and then we have the employee table, where we have information about the employee. So right off the bat, we know that department has one-to-many employees, and in this particular instance, employee belongs to one and only one department. Again, that's specified purely by business rules. It's not something we would necessarily decide. It's something the organization as a whole would decide upon. So with that said, we also have department has a boss, which is an employee. So that's what this second relationship is. And whenever you have a one-to-one relationship like this, it's important that we label it so it's clear as to what it is and why it is present. So in this case, of course, we have department's boss as the label. So that's something that are important to do. If you have a one-to-one, just make sure it's labeled. So, you know, within this, though, we could actually think about this in a recursive sense, where the employee has a employee's boss, which is also an employee. So when we have that, we see that employee has one boss, but a boss could be the boss of one-to-many employees. That's how we'd represent that. So either of these two options right here, where we have the one-to-one or we have the one-to-many recursive relationship with itself, they both mean the same thing. So we could certainly pick whichever we prefer. Generally speaking, you're going to want to do this one-to-one relationship just because it's more clear and it's less confusing. But this is how we would go about implementing this should we ever choose to. So as you would with a one-to-one relationship, you also want to make sure that you label what exactly this recursive relationship is. Because you could look at this and imagine I had person with a recursive relationship to another person. What does that mean? I mean that person is another person? Hopefully not. That could be causing some problems, I imagine. Could mean a person is married to another person. Could mean that a person, you know, does stuff with another person. There's lots of different things as to what that. So that's why you make sure that you clearly identify what specifically the relationship means, if it's a one-to-one or a recursive relationship. You really don't have to for one-to-many relationships, or zero-to-many, of course, because that's going to be implied and understood. So any questions so far? Again, certainly feel free to let me know if there's any questions as we go. So whenever we have these one-to-one relationships, it's important that we plainly state what they are. So, to do that, we use a foreign key. So in this case, if we look back at this model, we know that department, we could easily place a foreign key for department boss. And that would eliminate all the problems with identifying this relationship. We know exactly which employee is the department's boss. Now, we could also put the department's boss inside of the employee table. That's not necessarily the best approach. Can someone tell me why that may not be the best approach? So why would it not be best practice to put the foreign key inside of the employee table here? So basically, if you put it inside the employee table, for some employees it will be null. Specifically, we look at this organizational chart here. Alice doesn't have a boss. So that's one problem. Another problem is you're having redundant information. If you have, let's say, 5 or 6 departments, that's going to have a lot fewer records associated with it than if you have, let's say, 10 or 20 employees. So you're able to save storage space. And if you put this on a larger scale, you can certainly see how this can greatly allow us some additional flexibility and reduce the amount of processing and storage that we need. So some reasons why you would do it. It's also more clear. So if you have a department with a boss inside of it, everyone kind of knows what's going on. Whereas if you have an employee, it may not be immediately clear as to which department they belong to. So there's a lot of different reasons why we would want to put it on the department side in this case. So, just some things to think about here. Does a department have to have a boss? Depends on the business rules. We don't know. So for example, for the managing director, do they have a boss according to business rules? They do not. That's exactly correct. So yeah, I mean, it really does depend upon what the organization sets regarding whether or not, we have to have that. So does an employee have to be a boss? No, they don't. That certainly wouldn't make logical sense for every employee to be a boss. That'd be pretty expensive on the payroll, if you know what I mean. But that's not the only reason, of course. If every employee is a boss, then no one's a boss. Because who are they going to be the boss of? Themselves? Well, that's self-employment. So it really just depends. Basically, what you want to opt for is you want to make sure that you're having the entity that has the mandate with the primary, the foreign key inside of it. So, it's similar whenever you're doing a recursive relationship. So we think back to this relationship right here where we had employee has a boss, and the boss can belong to one to many employees. Similar things we do. So basically, we would just add in another column for the foreign key. We just call it boss, something like that. And I'm actually going to move whatever this stuff is out of the way so you guys can see the board a little bit better. So yeah, certainly that's what we would be doing. We would just make sure that we have some sort of foreign key present. It's going to be the boss ID, or it's going to be the employee ID, but we don't necessarily want to, we can actually call it the employee ID inside the same table. Who can tell me why we can't use the same attribute name inside of a table? Exactly. I mean, it's like if you had a table and you had 2 of the same exact attribute names, it's just not going to let you create the table. For a lot of reasons. The most obvious reason being that it simply cannot, have 2 things the same. You can have a very similar name, or you could call it something different that's meaningful, but you can't call it the same thing inside of the same table. It differs a little bit from the one-to-one relationship. If we had the one-to-one relationship, we could call both of them employee number if we wanted to, but we don't have to. Whereas if we're doing a recursive relationship, because we're within the same table, we have to make sure we're using a different attribute name. Let me know if there's any questions about that. Is that clear? So we haven't gotten too complicated yet, but basically what we're doing here is we're just adding in employee number. This would be doing the one-to-one relationship here. We have the department name, department floor, department phone number, and then the employee number. That's going to be the boss. So I would say it'd probably be better practice. Instead of calling this employee number, call it boss. You walk into a room, you say, who's the boss? Well, you can say, one is the boss. I don't know if that makes any sense, but that's what this is all about. It's identifying the boss. So then you have the employee table here, and in this case, they actually did it kind of redundantly, where they also have the boss number included within the table. So they're showing you both different ways to go about modeling this and the approaches and what that would look like. So as we can see here, we have information about the employees, we have information about the department. Both tables have the boss. Do we have to do it this way? We do not. Should we do it this way? I agree, Jarek. We probably shouldn't do it this way in most cases because we have redundant information. It's very easy for us to run a query and see who's the boss of which department. So that's exactly right. We probably wouldn't actually want to do it this way. But to go about creating this, it's very similar. It's like what we've seen before. So basically, we just do a create table for the department table. We just have department name, which we're defining as a varchar 15. Pretty straightforward. We have department floor, department phone, and then imp number. And in this case, we're defining the primary key as department name. So that should be unique to every department. If it's not, then that's going to be a bit of a problem. So then we also have the employee table down here where we're defining our attributes about the employees. But if we look down here at the bottom, we have the imp number, which is the employee number, defining that as a primary key. And then we're also adding in some constraints to use department name as a foreign key within inside the table. That's all that's saying. And then we're also adding in a constraint has a boss to look at the employee table to see whether or not someone has a boss. So that's all we're doing here is we're just adding in those additional constraints. So we don't have to do either of these two things. We could certainly get away with not doing it. And in fact, it's probably best practice to not include these two things inside the employee table. But this is how you would do it if you wanted to model it in two different ways within inside the same model. So now if we want to insert information into it, we can just do these insert statements. Of course, just a brief little reminder here. In this case, we're specifying the variable order and the variables we're inserting. If you didn't want to do that, you could certainly just start inserting the way they're described inside the table definition. But in this case, it's probably always best practice just to make sure that you're putting in the exact order. It can be better for you. It can be better for the computer to understand what you're doing. It's just a better approach to take in a lot of circumstances. So nothing really new here, though. We're just inserting data. So now if we take a look at these, we can kind of briefly talk about how we would model some of these relationships. So if we have a team can have a captain, we could have a person, or we could have a team member entity, and within that, we could have a recursive relationship where we define captain. So captain has one-to-many teammates, and teammate has one and only one captain. Now we're assuming in this case that the team doesn't have, some sort of dual captain, or what would that be called? Co-captain? I don't know. We're assuming there's only one captain on a team. So another way we could model this would be to have a team entity, and inside the team entity, we define the captain, and then maybe we have a player entity, and inside the player entity, we define which team they're a member of. So in that case, we would have team player would be a foreign key. We'd probably call it captain within inside of the team entity. And then inside the player entity, we would have which team the player belongs to. Now, of course, a potential problem with that approach is that we don't necessarily, there could be a case in which people are involved in multiple teams. Certainly, there's no inherent business rule saying you can only be involved in one team at a time. Sure, if we took a poll of the class, people in here have probably been on more than one team at once. So that's certainly something we could do. You can kind of see these. Let's see. So if we had a country with a flag bearer, again, it's going to be a recursive relationship. We model country, we get our country information, and then because it says a flag bearer, that means it's singular. So we have a one-to-one relationship there where one country has one flag bearer. So all we have to do is just put flag bearer inside the country table, and then we have that information stored. So any questions about this so far? Pretty straightforward so far. Well, so we wanted to query these relationships, pretty similar to what we've done before. So basically, we're wanting to list the salary of each department's boss. So as you may guess, we're going to use a subquery to do that. So let's take a quick look at this. We're going to first select the employee first name, department name, and then their employee salary from the employee table. But we're going to do this a little bit differently than before. Now we're going to do a where condition where the imp number is included within inside select imp number from department. You could also do select star from department. It'll give you the same exact results in this case. But basically what you want to do is to determine which department is, which person within the department is the boss. And those are the only people you're going to report the results for. So that's what this where condition is, a subquery where we're looking to see whether or not the imp number exists. If it does exist within inside the department table, then we're going to report the salary for that person. Of course, also the imp name and department name, but that's what we're doing here. So it's really not that much different than what we've done before, but it's important to understand how this kind of works. So now let's see how we'd list the salary of each department's boss. Here's another way we could do it. So of course we could get the employee first name, department name, their salary from a join condition. So in this case, we're going to join the department table on department.imp number equals the employee.imp number. Gives you the same exact results. So both of these queries do the same thing. They just do it in a pretty different way. So any questions so far? All right. So now if we want to find the salary of a particular person, of course we have the work table. This is actually going to be what we call a table alias, or we actually create this on the fly. So it's kind of cool that we can actually create a table inside of a query and reference information from that table we created. So this is going to be a little bit cool. Basically what we're doing is we're creating a temporary table to allow us to obtain information from it. So in this case, we're getting the employee number of Nancy here, and we see her boss number is 5. So then we go to our boss table here, and we see Todd as the boss. We would return 38,000 for his salary if that's what we wanted to do. Let's see how we actually do that. So the exact approach, this is what's actually new for this chapter so far. So basically, we're just making a table alias here. And to do that, we're going to go ahead and define the table alias name, which in this case is going to be WRK. That's going to be our work table alias. It's not an actual table. It's kind of like a view that we talked about earlier, but it's a little bit different than a view. So certainly it's similar, but not identical. So it allows us to do similar things. It allows us to work with it as we normally do. But unlike a view, this is not permanently stored. So even a view in and of itself, the data is not permanently stored within it, but the definition of it is. Whereas this, we define this each time. So basically what we're doing is we're selecting the table alias name dot the variable. So in this case, it's going to be wrk.emp first name, get the employee first name, get the wrk.emp salary, getting the boss.emp first name. So this is where we're going to define the table name dot variable. I think this is a good approach to take because it allows us to easily determine which variable comes from where, especially when we're using variables that have the same name but are in different tables. So we're going to do boss.employee first name, boss.emp salary, and then we're going to define this from emp work, join emp boss. So again, both of these are coming from the employee table. We're just making two table alias. I guess that'd be table alii. Don't quote me on the exact plural pronunciation there. But certainly that's what we want to think about is we have this from join statement. We're going to define what we're joining on. So we just say work.boss number equals boss.emp number. So those are going to be what we're joining on. Notice we're not joining on work.emp number equals boss.emp number. Can anyone tell me why we're not doing that? 5 points on exam 2 to who can tell me why we're not doing that. So actually, if you just used emp number.emp number, it would give you the person, because what would happen is, the work table and the boss table have the exact same attributes associated with them. So they all have the same thing. So if you're getting the emp number, let's say you're getting, in this case, 6 and 6, because 6 equals 6, you'd be getting Nancy's salary in that case. Does that make sense? So basically, then we're going to apply the where condition where the work.employee first name equals Nancy. So if we had those two things set to the identical imp number, then we would only be getting Nancy's salary even after we defined those two separate table alii. So any questions about this? This is the important part of the chapter. The other stuff we've kind of covered in some varying amounts of detail, but this is where it's most important from this chapter. So any questions? All right, certainly don't ever hesitate to ask any questions. But now we're going to do this query a little bit differently. We're going to find the number of employees, or the names rather, of employees who earn more than their boss. So kind of like last time, we're only going to return the name. So we're just going to select the work.employee first name. Because we're getting the names of employees, not the names of the bosses, we're getting the names of the employees. So we're going to get it from the work table. Select the first name from the imp work join imp boss. Again, we're just defining those two table alii within inside the from condition like we did before. And then we're doing the join condition on work.boss number equals boss.imp number. We're going to get the employee for, who their boss is to join that with the boss's employee number, basically. And then we just set a where condition where work.imp salary is greater than boss.imp salary. So because we just got that condition up here, where we set the equal condition there, we're able to easily query this and determine who has a employee that makes more than their boss. So in this case, it's going to return Sarah because Sarah makes $56,000. Her boss is Breyer, I guess, maybe Breer, I'm not sure, and they make $43,000. So $56,000 is greater than $43,000. Therefore, when we set this condition, it'll return the name of Sarah because that's all we asked for. So any questions about this? So we just did this. So we're just going to talk about it a little bit. Basically, we just do what we just did here, where we're selecting the employees that out-earn their boss. Just what we just did. So basically, we're going to move now towards having a one-to-one recursive relationship. Now, unlike the one-to-many recursive relationship, this is a special case of a recursive relationship where there's going to be one and only one of each instance. So in this case, we have someone who comes before a monarch. We have someone who comes after a monarch. That's always going to be the case. We can't have two people who immediately precede a monarch. That's just not how the monarchy works. Similar thing with a president. We have one president at a time. We look back, across the 45 presidents we've had, there's always someone before them, and there's always someone after them, unless we're looking at the current or the first. But, that's kind of beyond the point. Basically, that's what we're talking about here. We have a guaranteed one and only one relationship here. So it's often going to be dealing with time, not exclusively dealing with time. If we're talking about ordinal information, the order of things, that could also certainly be the case in which we would want to make sure that we're accounting for that properly. So in this case, we're going to have the monarch. We're getting the monarch type. That's going to be, I guess, king or queen. Getting the monarch name, whatever their name is. Getting the number. It's going to be like first, second, third, fourth, so on. And then we're getting their begin date for their reign. So whatever date they take the crown. I guess that's what it's called. I'm not English in case you can't tell. So certainly, we're going to have a monarch that succeeds another monarch. And monarch is succeeded by a monarch. So this is just a one-to-one recursive relationship here. We're easily modeling this by just adding in this single recursive relationship here. Because we have the monarch date, we can do this. If we did not have the reign begin date, we'd have no idea what the order of these are. If I list off King George VIII, do you know when that person was in office or in the crown? You probably don't. But if I list off they began their crown on this date, and then you have someone after them who began their crown on a subsequent date, you know the order. You can determine that. This is really cool. So what we see here is we can actually add in these two variables, pre-monarch name and pre-monarch number, to have as calculated variables. So in this case, we have all the information from the data model, plus we add on these two additional attributes that we define as we go. That's why they're italicized here. So we look at this, the primary key are underlined, monarch name and monarch number. So these two attributes right here uniquely identify each instance of the monarch entity. So as we look at this a little bit more, it means that we have to make sure that whatever we have, because it's a one-to-one relationship, this has to be unique not only for the monarch within the entity, but also it has to be unique for the pre-monarch name and the pre-monarch number. So in this case, we're only going to have William IV be the pre-monarch for one person within inside the entity. In other words, George V cannot be the pre-monarch for someone other than King Edward VIII. So that's just kind of the way this works, is that this is how we define this. Because we're setting this as a one-to-one, we have to have there only be one matching primary key. And of course, to do this, we can set some basic SQL constraints using the unique index. So basically, we're just going to assign that to be always unique, and it's going to prevent it from not being unique. So it's actually not going to let you input the data at all if it's not unique. So any questions about this so far? So let's just go ahead and create this table. Basically, we're just going to create the table, put in all our attributes. Here's where it gets interesting, though. So we're going to assign the unique index of unique monarch. We're going to go ahead and define that index. So an index we haven't talked about yet a whole lot. Basically, it's going to be almost like an attribute, but not quite. It's going to aid in searching through our database, running queries through our database, as long as we have it be unique. So we can certainly do lots of things there. But for now, we're just going to think about this as allowing us to add in this constraint. So we're defining this constraint by using the pre-monarch name and the pre-monarch number. We're also adding in a foreign key within inside of there to just make sure that we have that foreign key defined. So that's all we're doing, is we're just adding in the unique index, and that allows us to enforce the referential integrity of that one-to-one recursive relationship. So basically, we want to make sure that we're, of course, in a recursive relationship. We're inside of one table. That's pretty much a given. So we're just making sure that everything is unique. Each instance is going to be unique of that. And if we have a one-to-many, this doesn't apply, because we could certainly have maybe 2 or 3 or maybe an infinite amount of instances of a relationship that have the same foreign key. But because we're specifying this as one-to-one, we cannot do that. So that's the only case in which this would apply, is if we have a one-to-one. So basically, we could just insert rows. I think you guys get the point on this. Pretty straightforward, just the basic insert statement. So yeah, I'm not going to go through that too much. Yeah, so let's just briefly talk about this example right here. So design a database to record details of all Olympic cities. So right off the bat, if we want to have this, what should be the first thing we do inside of our data model? What's the first entity that pops into your mind? So we're wanting information about Olympic cities. We could get country. That's certainly an option where we define information about country. And then within inside a country, what entity will we have? City. So city is probably going to be the most important entity here, simply because we want to have the information about them. So what we're going to see here is that a city can host an Olympics more than once. So for example, I think London has probably hosted several. I'm not a real big Olympic historian. Anyone think of any other cities that have hosted multiple Olympics? Greece? I'm sure Greece has. Really don't know. But you can certainly see we're not having a one-to-one relationship here. That's all that's telling us. And then also recognize that each Olympics has only one predecessor and successor. So in this case, it actually partially is for the predecessor and successor, but each specific city can have multiple Olympics associated with it. It's just saying that there is going to be some order applied to them. So the 2004 Olympics have a 2008 successor. 2004 was Greece, wasn't it? I know 2008 was Beijing. You get the point. So basically, we just model this information, we'd have, of course, the one-to-one relationship model there. But then for city to Olympics, that'd be a one-to-many, because a city can host one-to-many Olympics. So if we're doing that, what does that tell us about the attribute we would have within the city? We wouldn't actually want to store which specific Olympic it had, because then if we had a case where a city had maybe 2 or 3 or 4 different Olympics hosted, we couldn't put that inside of one specific attribute. If we did that, it would be multidimensional. It's not just one dimension. We want to have nice flat attributes where they only hold one and only one value. So basically, we would have to have some other way to model it, probably an entity for Olympic. And we would say the Olympic time, we would say the Olympic location, or location city, whatever we wanted to do. And then from there, we could get all the information we needed. So any questions about this? All right. So if we wanted to query a one-to-one relationship, it's going to be pretty similar to how we've queried in the past. So basically, we're selecting what information we want. We're telling it where to get it from inside the for condition. We're setting the where to monarch name equals Elizabeth, because we want to see who preceded her. And the monarch number equals the second. Now, this is nice and simple. This is not so nice and simple. You don't have to worry about seeing this type of question on the exam when it comes to doing any sort of joins on top of these other table alii. You could certainly see one or the other, but I wouldn't combine them into one problem. So it's a little bit of a break there, I guess, but not too much of a break. Let's go ahead and talk about this, though. So we want to see, was Elizabeth II's predecessor a king or a queen? Now, in this case, we're not actually storing whether they were a king or a queen inside of the pre-monarch name or the pre-monarch number. So we have to do a subquery to get that specific information. So that's why this gets a little bit more complicated in the previous example. So basically, we're going to select the pre.monarch type. So as you can tell, we're going to add a table alias called pre from monarch cur join. So we're also going to add in a table alias called cur. That's going to be for current, I'm assuming. And then, of course, we're going to do the join pre on cur.pre-monarch name equals pre-monarch name, and cur.per-monarch name equals pre.monarch number. So right off the bat here, it's a little bit complicated. Basically, all we're doing is we're just getting the person who preceded, in this case, Elizabeth II. We're seeing whether or not they were a king or queen. But to do that, we have to do that somewhat complicated join with 2 table alii. So that's basically all we're doing here. And then, of course, as you could guess, we're setting the current monarch name to Elizabeth. It's given inside the problem, as well as her monarch number to second, which is also given inside the problem. So any questions about this? Again, you won't see a question quite like this on the exam. I'm not going to combine those 2 things. And if we want to see what this looks like, basically we have the cur table alias, and then we have the pre-table alias. And we're getting this one specific piece of information. All we're selecting is that one monarch type. So we did all that work for one word. A lot of work, isn't it? So if we want to list all the kings and queens in ascending order, of course, all we're going to do is we're just going to apply an order by. So it's going to go toward the end of the statement. We're just going to order by. In this case, it's reigning beginning. So whatever their begin reign date was, whenever they took the crown or whatever they take, that's all we're going to do. Is we're just going to select the information from the monarch table. So basically, if we wanted to model a many-to-many relationship, this can be a little bit complicated, but not too complicated, actually. This is certainly easier than the last example we just had. So imagine we have a bill of materials. And we want to have products that are made from the materials. So imagine we're a company like IKEA. What does IKEA sell? What is one thing they sell?
Furniture.
Yeah. That's exactly correct. They sell furniture. So, as they're selling that furniture, they have different things associated with the furniture. So, for example, if you buy a desk from IKEA, you have several different options. You can customize what specific parts you purchase. So, for example, if you bought a tabletop, you could get your own choice of legs. you're not limited to one specific type of table. Like, you can actually select several different types as long as they're within the same family. So there could be multiple assembly guides that use multiple products, and a product can be used inside of multiple assembly guides. And in fact, a product itself can have multiple assembly guides associated with it. So imagine we had a desk assembly guide, and the desk has a tabletop and some legs. But the same thing is using multiple products. And the products can also, of course, use assembly guides in and of themselves. So it's a little bit confusing when you think about it. But if you just model this as a many-to-many, and it's not too hard to work with. It's really the thinking that's going to be a little bit tougher inside of this specific example here. So here's just another way we could kind of show this. It's really the same thing. We're just having two recursive relationships saying that product can be involved in 0 to many assemblies. Assembly has one and only one product, which is not entirely true. But then also, assembly can have multiple products associated with it. So if we just map this out, we can, of course, see we have our product table here where we have all the different products, and then we have assemblies. So these are going to be like some sort of packages in this case. So imagine you're a photography store. You sell an animal photography kit. Well, what's inside of the kit? Certainly, you're going to have things like a camera. If you look at the product ID 1000, you're going to have the camera case, some sort of zoom lens, some other zoom lens, and this is all inside the 1000 product ID here. So basically, all of this stuff is included within this one item inside the same table. So a little bit complicated, but not too hard to work with, actually. So to create the table, we do like we would expect. We create the first table, product. In this case, we're not applying any constraints to it. So as I've said before, you pretty much pick whichever table you don't want to have constraints, and you don't apply the constraints to them. Because at some level, you have to input the data. And you can't input the data if it has a constraint that it must be present within another table. It's like, which comes first, the chicken or the egg? Well, you can't really answer that. At some point, one of them had to be in existence, you know. So you wouldn't necessarily have the constraint that a chicken must have an egg, because what if at some point there was a chicken that didn't come from an egg? That's kind of getting a little bit philosophical there. But certainly you can imagine we wouldn't want to apply the constraints to both tables. So as we can see here, we have the product primary key we're using as a composite key comprised of product ID and subproduct ID. So we're just going to do that as a composite key. Then we're applying the constraint. We're just using the foreign key product ID as well as the foreign key for subproduct ID. Of course, we're just referencing product ID for both of those from the product table. So then if we want to run a query on this, it's not too difficult. Basically, we're just going to select the information we want, tell it where we're selecting it from. We're going to do a join between the two tables. So we're just going to join the assembly table in this case to find what the condition is we're joining on, which is going to be product.assembly or product.product ID equals assembly.product ID. So we're just keeping it nice and simple here. Then we're defining where the product description equals. In this case, we're setting that to animal photography kit, because that's the only product description we actually have. All these others are subproducts, technically. Basically, we could also list the product description and cost if we wanted to. So we could just kind of put the query on here, really similar to what we did last time. Only in this case, we're going to add in a subquery because we're getting multiple pieces of information. So we just get the product description and product cost from the product table, but we only want to get it where they're included within inside this animal photography kit. So we add in a subquery for a where condition, subproduct ID from the product table, join assembly. We define what we're going to join on. In this case, it's going to be product description. So we're going to set that to animal photography kit because that's the information we have given in the problem. And then we're just going to do the where. We're just going to assign it as you'd expect, product.product ID equals assembly.product ID. And then when we run this query, of course, we're going to get all the product description and the product cost that are included within inside the animal photography kit. So pretty straightforward. If we wanted to briefly talk about these, model the following situation. So you have friendship. So you have, let's just say you have a friend entity. Does a friend have one and only one friend, or do they have one to many friends? Hopefully one to many. If you only have one friend, we'll I don't know what to say, but yeah, that's probably, you want to have many friends. That's certainly a good thing. You could also do person, and you could add in a friendship entity if you wanted to, and then you could have, certainly you can model that a lot of different ways. Probably the best way though is like Maxwell was saying, was to use just a single friend entity and then put in a recursive relationship one to many. It's gonna be the most clear way, I think. What about course prerequisites? How would you want to model that? Yeah, that's certainly a great approach, is to have, the course and then have different prerequisites associated with each course. Lots of different ways we could do that. We could also define a prerequisites table where we have what the prerequisite is of, and then we could also have, the course that the prerequisite is of, and then we could have a specific attribute for, what the prerequisite is. So for example, in this class, I believe the prerequisite is, I don't even know. It's probably in the syllabus somewhere. Let's see. Let's see here. Well, it's not in the syllabus, but I believe it's I believe the prerequisite for this class is one of the introductory programming classes we offer. I got no idea what the numbers on those are, but it's probably one of those, and could be 2 or 3. So if you have a table, you would have BIS 3753 as the course that you're having the prerequisite for, and then you would have an attribute for what the prerequisite is. So let's say, I'm just going to say BIS 1000 and then BIS 1001. You'd actually have 2 instances of that, and that would allow you to appropriately model it. So there's lots of different ways to go about modeling these. I'll just kind of wrap things up today. We covered the recursive relationship. We talked about where we may see the one-to-one recursive relationship, why that's a special case. We also talked about different types of referential constraints you may want to apply. And then we also, of course, covered the most important topic, which is the table alias. So any questions about today? All right, that's all I've got today. I hope you all have a great day. I will see you all next class.